Okay guys, just in case we're having trouble getting started here, okay, here's our cliff, okay, there's our car, and it's going to drive off the cliff, and it's going to do this, and it's going to end up down here in a flaming pile, okay. So we know that it drives off the cliff at 25 meters per second, so VI is 25 meters per second. Okay, when it strikes the ground below, that would be here, okay, it is moving at 53 meters per second. Okay, they want to know what's the height of the cliff, which would be the initial height of the car. All right, so remember, you need to write out your EI equals EF, identify what kind or kinds of energy are present, initial and final, plug in your formulas, manipulate and solve. Okay? So, there's no work being done here, right? Like nobody is like making the car fall faster as it goes off the cliff. All right, so that would mean that no work is being done, so energy is conserved. The initial mechanical energy equals the final mechanical energy. All right, and that means the initial potential plus the initial kinetic equals the final potential plus the final kinetic. Now, are any of those zero?
Yes.
Which one?
Final potential.
Final potential, because the final height is zero, right? Okay, so final potential is zero, I can get rid of that. What I'm looking for is the initial height, which is part of this. All right, so I want to get the initial potential by itself. What do I have to do with the initial kinetic? If I want to move it over here, subtract it over to the other side, right? If I want to do the opposite, if I want to move something. So I'm going to have the initial potential equals the final kinetic minus the initial kinetic. Now I've got initial potential by itself. Okay? Are we still following all the same steps as yesterday? Yeah. Now I can plug in my formulas. M times G times H initial, okay, equals 1/2 MV final squared minus 1/2 MV initial squared. What did we say about M yesterday? That you don't need it. If you're not given it, it's because I forgot it. And I forget it all the time because I never use it because you don't need it. Okay, so if you have a question like this and you're not given the mass, you didn't need it in the first place. But obviously on an exam or a quiz, I will give it to you. Okay, so I'm going to get rid of the m's. And I just want to get HI by itself. What do I have to do with G? Just divide it over to the other side. All right, so the initial height of the cliff, 1/2 times 53 squared minus 1/2 times 25 squared. Divided by 9.81. Sorry, I forgot to fire up my calculator. Okay, 0.5 times 53 squared. Okay. Minus 0.5 times 25 squared divided by 9.81. Whoop, obviously not that number. Divided by 9.81. Okay, so the height of the cliff was 111.3 meters. Okay. Did that one seem a little crazier when you started it? Okay. First time I've asked you for one of the initial values, okay. But in the end, the pattern is still the same. Okay. You're just trying to isolate that thing you don't have. All right, any questions on how that works? Kind of ringing a bell from yesterday? Okay, we're going to spend some time working on these today, guys. Tomorrow, okay, we'll probably, we're going to do our unit exam review tomorrow. And then on Monday, I'm going to teach you the last thing, which is efficiency, which won't take even half the class. And then we're going to move on to the stuff from Unit 4. Okay, so we're moving along really nice. Okay, right now. Okay, so try this one. Skydiver, right? Parachute not open, so in free fall. Because if you open the parachute, then you got work going on because something's going to slow you. Okay? This person just jumped out of a perfectly good airplane. They have a parachute. They just didn't open it yet. All right, so person jumps out of the plane. Okay, so they're here. That's the person. Okay, and they are at an initial height of 10,000 meters. Okay, then we're looking for the other spot, which is at 8,000 meters. Okay, down here is death at a height of 0. So we're not dealing with that spot, but that's where everything is measured from, obviously. Okay, so how fast will the skydiver be falling here? So we're looking for their final speed. Okay, and we are also given that they jump out of the plane at 90 meters per second. Okay, now here's what sometimes people try to do. They see what they think is a workaround here. Okay, and the workaround that they see is that they could do this as an acceleration question. But you can't, because what don't I give you? I don't give you the time, and there's no way for you to calculate it. And the second thing, the 90 meters per second isn't down. When you jump out of a plane, it's moving horizontally. So are you. It never looks that way when you see somebody jump out of a plane because they start to accelerate vertically right away. Okay? But they're actually moving horizontally at 90 meters per second. And energy is scalar. It doesn't care which way you're going. So when you calculate the final speed, what they're actually doing when they jump out of a plane is this. Exactly the same thing the car that drove off the cliff did. It's a projectile. Okay? So when you calculate how fast they're going at 8,000 meters, you're calculating their speed, not their velocity. Okay? That's why you can't solve it as an acceleration problem. Everybody with me there? Okay. So, let's undo those last two things. Come on. All right, so we're looking for VF. There's nothing doing any work here. It says specifically that the chute is not open. They're in free fall right now. Okay, so that's going to be EP initial plus EK initial equals EP final plus EK final. Are any of those 0 in this question? No. Okay, they have initial kinetic, courtesy of the 90 meters per second. They obviously have initial potential, 10,000 meters. Okay, we're looking for how fast they're going, and it'll be faster at a height of 8,000 meters. So they have all 4 of these. None of them are 0. I have to keep them all in. What I'm looking for is part of that term right there. So how do I get EKF by itself? Subtract EP. Right. So I'm going to have initial potential plus initial kinetic minus final potential equals final kinetic. Okay, once again, did they tell you the mass of the skydiver? Do you need it? No. Okay. So M times G times H initial plus 1/2 MV initial squared minus MGH final equals 1/2 MV final squared, and I'm going to cancel all the M's. Okay. Again, on a quiz or a test, I will give you M, and you can totally leave it in there and put it in for every M if you like typing on your calculator. Okay, but this is a shortcut that you can do. All right, want to get VF by itself. What do I have to do with the 1/2? Divide it over. Okay, so now the half is gone. That solves for VF squared. I want VF, so what do I have to do? Square root. Okay, so pretty patterned, right? We're just following that same thing every single time. 9.81 times 10,000. Okay, plus 1/2 times 90 squared minus 9.81 times 8,000 divided by 1/2. So initial potential, initial kinetic, final potential, okay, divided by 1/2 square rooted. Okay, that's fast, but not unreasonably fast. Okay, if you jumped out of a plane, you could fall really fast. Okay, 217.6 meters per second. Okay, in this situation, that would be possible because we would imagine that there's no air resistance because air would do work. In the real world, could you go that fast? No. You reach terminal velocity, which is much slower than that because air starts to work against you. The force of air resistance will start to slow you down and you'll fall at a constant speed once you get to your terminal velocity. Remember, we're doing all of these questions in what is an isolated system. So there are no forces that can do work. Air resistance can do work in the real world. Not that terminal velocity isn't fast enough to kill you, it totally is. Okay? And it's also scary fast. It's just not that scary fast. All right, questions on that one? Okay, how are we feeling about these? Okay, quick review from yesterday. Sometimes work energy theorem questions give us similar givens. How do I tell them apart? What will a work energy theorem question always give me or ask for? Force. Okay, a conservation of energy question never gives force. Forces do work. Conservation of energy problems can't have any work in them. Okay, also, a work energy theorem problem is going to give you either two velocities or two heights. A conservation of energy problem could give you two of each. Okay, so in a work energy theorem problem, it's going to be a change in kinetic energy or a change in potential energy. In a conservation of energy problem, okay, you're going to have both kinds. Right, so you won't. That's how you can kind of tell them apart if you're ever confused. Okay, the biggest one, the biggest flag is force. Okay, if you got force, or you ask for force, or you see the word work, it's definitely a work problem. Okay, if you don't see those things, then it's a conservation of energy problem. Also, the contexts are different. Okay, in a work energy theorem question, they're going to say things like it's pushed, or it's pulled, or it's lifted. Okay, things like that involve a context that makes it obvious work is going on. Okay, whereas in a conservation of energy question, it's almost always something sliding down a hill or falling. Okay, or a roller coaster on a track, which is still sliding, okay, on a hill. All right, so those are kind of the contexts to watch for, because I find on the unit exam, that's the stumbling block. Not that people can't do the problem, they struggle to identify which one to do. Okay? All right. Come on. Really? Okay, on question 15, you kind of have to make a chart, and there's something I want to show you when you've got that chart done. It is asking about the different positions of the rock as it falls. So what you want to build, okay, for number 15 is going to look something like this. Okay. All right, so you have like your height, okay, and then you'd have like EP, EK, and then I think there's also probably going to be one here for toe. All right, and then so you'd have your heights here, so you just kind of make a chart like this, and you're going to fill it in. Okay. The nice thing about that is that question seems like a lot of work, but once you recognize what's going on, it's a lot less than you think. Okay. All right, put them back up here. Okay. If you're having trouble with this stuff, guys, let me know. I'll come around and give you a hand. Okay. It's just a matter of practicing the pattern. Okay. There's definitely going to be one of these on your unit exam on Tuesday. Okay, as I said, you're going to make up a chart, right? You know that it's a 2 kilogram rock and it's released from 20, and we're going all the way down to a height of 0. Okay, so 2 kilograms starting at 20 meters. Okay, so we got 20 meters, we got, is it 10, 5, and 0, or 15, 10? 15, 10, 5, and 0?
0.
Just down to 0, okay. All right, when I drop it, how fast is it going? Well, that's how fast it's accelerating. How fast is it actually going? Anytime you drop something, the initial velocity is? Okay, so how much kinetic energy does it have at the initial point of 20 meters? Right. Okay, can I calculate how much potential energy it has?
Yes.
Yeah, I just have to go m times g times h. Okay, so if I go 2 kilograms times 9.81 times 20 meters, I've got 392.4 joules. Okay, and then my total is 392.4 joules. Can I put that number in every box all the way down? Yes, I can, because the total mechanical energy at any 2 points has to be equal. Okay, that's what EI equals EF means. All right, can I calculate the potential energy for all of these points? Yeah, in fact, for this last one, I can do this. 0 and 392.4 joules. How did I know to do that? Yeah, it's on the ground. And all of its energy on the ground would be kinetic. Okay, if the total mechanical energy at a height of 0 is 392.4 and none of it is potential, then the kinetic has to be 392.4. Okay, so back to my original question. Can I calculate the potential energy at 15 and 10 meters? I have the formula for that, right? And since I know what it and kinetic energy add up to, I should be able to calculate kinetic energy in the other 2 boxes. I'll let you do the rest of that before I fill in the rest of the chart. Okay? Okay, so because I have mass and gravity and height, I can calculate the potential energy for these 2 missing boxes. Okay, so for 15, it's just going to be 2 times 9.81 times 15. Okay, I'm going to get 294.3. Okay, joules. All this question is asking is, do you understand that to calculate mechanical energy, you have to add potential and kinetic together? Okay, that's really all it's asking. So now, if I want to find the kinetic, I just subtract this from the total, and I'll have the kinetic energy on the way down. So 392.4 minus, okay, so I've got 98.1 joules worth of kinetic energy there. Okay, and then for the 10 meter one, mass times gravity times height. Okay, 196.2 joules. Okay, I'm pretty sure this comes out to 196.2 joules as well, but we'll do the math anyway. Okay, so 392.4, okay, minus 196.2 is 196.2 joules. Okay, there we have it. All that question was asking was a conservation of energy question, but also, do you remember that EP plus EK equals mechanical? Okay. All right, how many people are done the other ones on 16 and 17? Okay, let's keep going on 16 and 17. Identify that. All right, so if we're looking at number 13, okay, this car is coasting through a 50-meter long snowdrift that has been blown onto the road. The car starts at 20 meters per second before it reaches the drift, and then it emerges at a speed of 8 meters per second. Did anything other than kinetic energy change in this question? Okay, and if you're going to slow something down, does that require work? It absolutely does. Okay, now they do tell you that the length of the snowdrift, which would be the distance over which the work is done, is 50 meters, and the question specifically asks for you to calculate force, right? Which means it has to be a work energy theorem question because force is never part of a conservation of energy question. So you can see that in a question like that, the context is very different. There's obviously something being done. Work is being done because the energy is changing. Okay? If this was a conservation of energy question, the car would have gone right through the snowdrift and not slowed down at all, which is impossible. Okay? So in this context, work has to be done. Okay? So if we bring that over, come on. Okay, so if we bring that question over, okay, we know the mass, okay, it's 5,000 kilograms, that's 5 times 10 to the 3, okay, we know the distance is 50 meters, we know the initial speed to be 20 meters per second, and we know the final speed to be 8 meters per second. All right, obviously work is being done and it's changing the kinetic energy of the car. All right, that's going to be force times distance equals 1/2 mv final squared minus 1/2 mv initial squared. All right, since we're just looking for force, all we have to do is divide both sides by d. All right, so it's not like a really algebraically difficult question. There's not much to do here other than move the d and plug in the numbers. Right? What's tricky is you've been doing a bunch of other questions and you got to switch, right? You got to be able to switch gears to this one. All right, so force is going to be then 1/2 times 5,000 kilograms times 8 squared, the slower of the two because it's the final, minus 1/2 times 5,000 times 20 squared, the larger of the two, and then over 50 meters. Now this does come out negative because force is a vector quantity, and in order to slow something down, it has to act backwards. Okay, so when we plug in our numbers here, I think it comes out to 16,800 actually, joules, which is rounded up in significant digits to 1.7. Okay, but it is negative when we do that because the final kinetic, is smaller than the initial. Okay?
Why is it joules?
Oh, it's not. It's in newtons. Good catch. Come on, I want the eraser. It is in newtons. Okay. Any other questions on that one? All right, so that's what you got to expect on your unit exam, right? You're going to get a work energy theorem, probably one of each, one potential, one kinetic, a conservation of energy question. You got to be able to tell them apart. All right. Okay. Couple of things here. So tomorrow, obviously, we're doing our unit exam review. Okay. This is it, other than efficiency, which is super quick and easy. Okay, and we're doing that on Monday. June 3rd is Tuesday, so that's your unit exam. And then straight into the last unit. It's not going to take us very long at all. I will put up the final exam, or the unit exam date. Okay, for that it'll be like probably next Thursday, probably be like June the 12th. Okay, it's going to come fast because that unit's really short. It might be June 16th. We'll have to see. It might be that very last day. We'll just kind of see where we sit. Okay, but it'll be around there. You guys just listen for a second. Okay. In regards to assignment completion and the mock final, okay? Remember, the mock final is optional. You do not have to write it, okay? But I will put out a Google form closer to the time, okay, to those who are eligible to write it, okay? And if you want to, you fill it out, and I'll make sure that there's a mock final for you on the day you choose. Okay, so inside the form, you'll put your last name, your first name, what class you're in, and what unit exam you want to have replaced if you do better. Okay, so you basically just check. If my lowest unit exam was unit 1, you just check that. Okay, and then I'll know to replace your unit 1 exam mark if you do better than the exam mark you already had. Okay, and then yeah, you just pick your day. Okay, these are the 3 times. Okay, June 18th at 9 a.m., June 18th at 1 p.m., June 20th at 9 a.m. I would imagine that's the one that's probably going to work for grade 10s better because there aren't any grade 10 exams that morning. Okay, but you pick whichever one works for you. If you want to do one of the other 2, that's totally fine as well. Remember that overdue assignments are accepted until June 13th at 12:20. Okay, so that's the end of the day that Friday. If you want to be eligible to write the mock, and of course have the highest mark possible going into your final exam, that's the last day you can hand anything, and I won't be looking at Google Classroom after that. Okay? All right, any questions on that stuff? Okay. All right, so like I say, I'll put that Google form out in a little bit. So obviously no quiz tomorrow. Okay, we're doing our unit exam review, and you won't have any more quizzes. We're done, don't have time for any more. Okay, that's all the time we have. Okay. Good job today, guys.